My name is Swetha. I'm also a UC Berkeley grad. That seems to be like a theme in the speakers. So I graduated a few years ago, I got a BS in EECS, and then I ended up at IBM, and I do purely open source development, which is great. So when I come and I'm showing you Hyperledger, I'm going to show you Hyperledger Fabric, Composer. Everything that I'm doing is open source. All the code is available for you. But what I am going to show you is a demo, a tutorial that IBM has developed. So that's kind of my plug for IBM Blockchain. So as people kind of come in, one of the cool tools, and this is kind of where my code is, so in case you want to follow along, do this at home, I'm going to make that. That didn't help make that bigger. The website is developer.ibm.com/code. I mean, if you do IBM code, you should quickly find it, but the reason why is this link right here that says code patterns. You can click on it, and then there are all sorts of options depending on the technology you want to learn more about. The one that I'm going to focus on is this one. Let's see if it loads. It's called Decentralized Energy with Hyperledger Composer. So I think somebody had come up and was asking before they get lunch, like, where do you see blockchain going, or where do you think the potential is, kind of? And my answer is kind of always like, you never know. I think, personally, I believe that blockchain is more than just cryptocurrency. I think there's a lot of use cases out there that can benefit from it. And that's the whole point. Each network has to be based on the use case you're trying to solve, right? So one of these, and it's really funny that this is the use case that I picked. So basically the idea is, say you are a bunch of residents and you're all on the same energy grid. And the idea, and Alex kind of mentioned this, like, you know, I have solar panels. I might not be using all the energy that I'm generating, right? So it'd be nice if I can get paid for that excess energy and give it to someone else. And similarly, like if you have solar panels, but you don't produce enough energy, maybe you're not, you know, situated with enough sun or anything, you want to be able to get energy from another resident. Maybe they'll give you a slightly better deal than if you go to the utility company and try to get energy. I mean, there's a lot of different ways. And just to kind of highlight how would we try to create that kind of a network, that's what this whole process is going to be. So there's this tool. It's called Hyperledger Composer. It's basically, so is there any Ethereum developers out there? No? OK. So this is kind of like a nice equivalent to the Web3 library, which kind of makes developing smart contracts a little bit easier. I like to think of it as like Web3 and Remix or Truffle. These are all IDEs to create smart contracts. Those put together is kind of what Composer is for Hyperledger Fabric. So Mohan was kind of talking about the different transactions, the ordering of the transactions. The client or the application has to send it out to endorsing peers. Then they have to collect all the endorsements and then pass it on to the order. I mean, that's a very complicated thing for a client to have to remember and deal with at the application level. So that's what this tool is kind of doing, is you give in the business logic, and it will manage the blockchain network for you. So let's talk about kind of what I was mentioning before about our energy network. So this is kind of a declarative tool. You can say these are the participants, these are the assets, and these are the transactions we want to be able to have. So just, this has already kind of been predefined, but we can create things like participant, there's a resident, we have a bank. The reason we have a bank is because possibly you need to be able to transfer money, that kind of a thing. And then you also have utility companies, because we were talking about how energy can be coming from residents, but it can also be coming from a utility company if there's no resident with it. And then these are kind of assets. So the thing that we're thinking about here are coins. So the coin, you can think about it as like each coin is going to give you, is equivalent to maybe like 100 kilowatt hours of energy, some kind of a value over there. And then energy, again, this is kind of like 1 unit of energy. So that would be like something like 1 kilowatt hour of power. And then you have cash, because you want to be able to pay for your coins. And as a resident, I just don't want tokens sitting in my account. I want actual money if I give it, right? So these are kind of like the assets you can define. And like you can see that this is like very simple. You don't need to have too much programming background to be able to create these kind of assets. It's a very declarative model here. And if we go back up to the participants, you can see that they've declared things like coins, cash, like a bank, that's what you can define how the bank has, the assets they have. A resident can have a combination of all of the coins, cash, and the energy. That's their meter reading. And then the utility company, again, coins and energy. So once we've created all these assets, the next thing you kind of want to think about is transactions. And the two main ones that we were kind of talking about just in describing these assets were a coin has some kind of value associated with energy, so there has to be some kind of transfer there. And then you also want to be able to pay for coins, right? So there's really two main transactions that are going to be occurring in this network. Now, this file is just very declarative. There is no code in here, there's nothing, and we haven't defined how these transfers work. But this is like the first step. We've defined all the participants, we've defined all the assets of the business network, and then we've also said what kind of transactions we're going to be using. So the next kind of file that we would want to be looking into is this script file. So this script file is a way to actually define your transactions. So the way this works is if you can see, one sec, the screen up there is a lot brighter than on mine. You see this energy to coins transaction. This is just kind of a tool for you to know as a comment. But these tags over here are actually very important. So when it says @param, it goes and it does this energy to coins thing, if you can see what I'm highlighting. And that actually correlates to this transaction right here, energy to coins. So what that says is, as a function, right, update values is going to be of type energy to coins, and it's going to have all those values that we saw in our model, right? So it's going to say how much are we exchanging, who's getting it exchanged to, how much energy change, all those kind of information. So what you can do in the script is you can create, you have all those informations. You have the energy rate, so that's basically how much energy is associated with one coin, and then how much energy we actually are converting. So you get the coins change, and then these coins increase, coins decrease. These are pointers to the actual asset that has to be updated. So these assets could be owned by different people. Like as we saw, like a coin is going to be owned by some kind of a participant, which would be a bank, a utility company, or a resident. And all we're doing basically is updating these values. Now, this by itself doesn't do anything. That's just code. That's to do your calculations. But the important part is like line 33, where you're basically saying, here, commit these type of transactions. This is what I want committed to the ledger. And this is also atomic. So if one part of that fails, none of it goes through. We don't have to worry about, oh, okay, I accidentally updated, taking the money from the participant 1, but I wasn't able to successfully do participant 2. All the read-write is kind of done in one shot, and that's kind of part of that endorsement policy, and that's because of how Fabric, the underlying network below, kind of deals with it.
Quick question. On this one, I was talking to Mohan, but he said that when you create a transaction, you can specify the endorsing nodes. Mm-hmm. Is this where you put them?
No, so this is above Fabric, right?
So it's just the chain code, right?
Yeah. So what this is a tool is, what it's going to do is it takes the code, all the things that you have defined. So this is at creating the chain code, yes. What it's going to do, Composer as a whole, is it's going to take all this data, all these declarative models that you've done in all the scripts, and it's going to create a chain code and deploy it onto the network. But at the same time, what it's going to do is the Composer as a whole also knows an idea of how the Fabric network is. So it knows who the endorsing peers are and all that. And I'm going to show you later on what Composer gives you. So that way, as a person, as an actual individual creating a transaction, you don't have to worry about knowing which peers to send it to or anything. Composer kind of takes care of that for you.
But you have the flexibility of doing that, correct?
Manually?
Yeah.
Yes. Yeah. So this is just defining, again, the transactions, right? And then you have a similar kind of approach to cash to coins. I'm not going to go through these other files here, but just to give you an idea, and if you want, of course, all this code is online, so you can use it. They have like an access control, so you can kind of have rules about what records people can actually access based on, what they're, like for example, residents shouldn't be able to access, everyone else's data or something like that. And then there's like a queries file, and I think it's important to know that there is a file like this, but more for the next step. We don't need to go too much into it, but this is just a way to be able to query the ledger based on the data that we're creating for this network. So once we have all of this, and this is kind of just a cool toy right now, you can actually test out your network right here. And this is kind of like, it's a playground. They call it Composer Playground, which is very similar to like the Go playground if you're Go developers. But basically, it's a way to test things out. Like, for example, you can create one. You can put a name in here. You can give values for how much you have. And then you create new. But this is all very, JSON-oriented. You still have to kind of do the parsing and figure out transactions. But that's just a tool for you guys to play around when you guys have the chance. So the next thing you would want to do is this export button. So if you do it, you create something called a business network archive file. Basically, it's consolidated all that information that we've created. And the next step we're going to do is actually deploy it to a Fabric network. So for the purposes of this, I have a local network right now. Actually, let's do this. I'll bring up a new one because I can see that the demo has already been done. Okay, well, I'm going to ask you to ignore that first one. That's me doing the demo previously. But really what you need to be looking at is here, there's a peer. The CA is the membership kind of service tool that is in Fabric that allows you to register new users and stuff like that. And then there's only one order, and CouchDB, as we already talked about, is for storing the state. In this situation, it's a one org, one peer. This is not a realistic situation, but this is just to demonstrate what would happen. So the next thing we would want to do is we want to create a peer admin card. So this is a way for Composer to be able to talk to the Fabric network. What it's using is credentials for the one of the admins of the network. So that way, they can deploy chain code. So you have to be admin access to be able to do anything that actually alters the nodes. So once this card has been created, we can actually just use, Composer, by the way, is like a Node.js tool. And you just have to do network install. So you're saying the card is just saying which user to use. You're going to use peer admin. And this archive file is that BNA file that we had downloaded before. And I actually have to be down. And then the other thing important to understand about how chain codes work in Fabric is it's a two-step process in installing a smart contract. One, each node has to install, right? So if one node installs it and then you start running transactions on it, the other nodes can't catch up. There's no way. So there is a manual step where each node has to install the chain code, and then after that, each node has to start it. So this first step of network install is doing just that. Okay. One second, I'm going to. Okay, so what this is doing is starting up a local Fabric just using Docker Compose, I believe. And it's just going to take a second. Yeah. So while we wait on this, let me tell you what I do currently. I said I mentioned before that I work on Fabric. What I actually do on Fabric currently is trying to get the EVM, which is the Ethereum virtual machine that Alex spoke about before. I'm trying to get that integrated into Fabric. So what that means is you would be able to run Solidity contracts and maybe use some of that Ethereum tooling that people like so much. They can use it on Fabric, but you get all the permissioning, the security, and the privacy that Fabric gives you. But you can bring and migrate your contracts a little bit easier. Is
that a project under like the Linux Foundation, or is it a separate project?
It's part of the Hyperledger fabric. It's an actual project, a feature that we're trying to push. So Hyperledger Fabric is actually part of the Linux Foundation. And then Hyperledger itself has multiple projects underneath it, right? So what we're actually doing with the EVM is Burrow came out with an Apache 2.0 licensed EVM. And so we're taking their implementation and putting it into Fabric. So Burrow and Sawtooth have already done that kind of integration. So we're trying to also be able to do that. And just FYI, the Hyperledger, the entire foundation, everything has to be Apache 2.0. Quorum and all of these are GPL licensed, which I think they play a role when you want to try to take this into an enterprise level kind of thing. Limits your ability to do things or not do things. Okay, so we should now be in the state that I had wanted to be in. So now you can see I have the peer, I have the CA, I have an orderer, and a CouchDB. So we're going to start back at trying to deploy this. Composer, network, install. Again, so I've installed a new peer admin that's going to use the new credentials for that new network and this archive file. Okay, so that command succeeded. I'm going to just show you to confirm this actually isn't running anything. All I did was install the code onto the peer, but again, it's not running anything. And then the next step we want to do is composer, network, start. So I'm giving it a network name. This network version is like, you can see that in this BNA file, the version, the network name are all kind of consolidated into it. Then again, I'm saying I'm doing this as admin, and these secrets are kind of predetermined based on the credentials you use to create the card. So I'm going to do that. This is going to take a second. Cool. And then, if you can see now, I have this container that's been started, and this container is running the network that we defined on Composer. So the way Fabric works is anytime you create a chain code, it's going to be run isolated from all the other chain codes. It gets its own container. So that, I think there was like a question about worrying about the code affecting, wherever it's running. This is kind of one of our isolation mechanisms.
The example that you're talking about, Walmart and having its own
food safety.
Food safety.
Yeah.
So that would run as its own chain code and all the.
You have to think about smart contracts as different from the network, right? So there's a network where Walmart will have all these participants. But for example, maybe Walmart has something for their first level suppliers. They have a smart contract that's only associated with those people. So that chain code will run there on the network, and maybe that's on a separate channel. There's like varying levels of granularity of what you're trying to do. So you have to think of smart contract as there's something that's being installed on all the peer nodes in the network, or in the channel, sorry. Yeah, in the channel, but then that doesn't necessarily mean that the entire network has to interact with that smart contract. You can have multiple, they can define different types of transactions, they have different.
Today they are disjoint. So on a per channel basis, the smart contracts, the blockchain and the state databases are completely disjoint from other channels, those SNCs.
So right now there's one channel for.
Can you just give an overview? I think we're getting lost in nodes.
Sure.
Just give an overview of where are we right now? I'm kind of a little.
Where are we in the step? Oh, okay.
Detailed code, I understand. So what are you trying to demo right now?
Oh, what I'm trying to, okay, so I'm going to try to draw this out and we'll see how well this works. Okay. So I'm going to just say this is our blockchain network, right? And in here, there'll be like peers, peer 1, peer 2.
And these are the nodes.
Yeah, these are nodes, and they can be owned by different organizations. I'm not going to worry too much about it. Composer is outside of this. And all it is it's taking your smart contract.
Composer being someone like me.
No, Composer is the tool that I'm using. Yeah. And it's just.
I showed you, Composer allows you to define what the elements of your use case are.
Okay.
The registry of users, the registry of assets.
Got it. Okay.
Yeah.
Got it.
So what Composer is doing is, like, once you have your network, you have to install chain codes. You can't just run transactions blindly. Like Bitcoin, for example, is one application for the entire network. This is more of the style like how Ethereum works, where you define smart contracts and you can have different applications running on the same network. So to define that application and that smart contract, that's where Composer comes in. The idea is we're trying to simplify the process of creating a smart contract. Because if you think about it, there's a lot of worries you're going to be worried about when you're writing code, especially when people aren't used to writing code in that way. So that's kind of what Composer does. It creates the smart contract based on your business requirements, and then it helps you deploy and install it. But it's all external. It has nothing to do with the actual blockchain network. It's just a tool on the outside.
In other words, you don't have to use Composer. You can do it all yourself, like I was saying. Composer just helps you do the job more effectively.
It's one of the ways to.
Yeah, it's like 4GL tools on a database system where they allow you to, in the case of 4GL, write your apps in a high-level language, and then they spit out SQL apps that you can install. Whereas here, it's along those lines, but not exactly.
So you're showing us an example as a composer writing the contract, and now you're going to submit it to stuff?
Yes, exactly. And then I'm just trying to show you what's happening on the Fabric side based on what we did out here, if that makes sense, yeah. So the idea is this is a chain code that's been installed now. But now that it's installed, you want to actually be able to use it, right? Submit transactions. And then again, Composer has created this really nice tool. So to do that, we have an Angular app that's been created already. So I'm going to start it. But if you see, oh, I missed a step, sorry. So the other thing is, like in a typical Composer, when you create a network, right, you're not going to give your admin credentials to everyone who wants to run the network. So this is what this tool is doing, is it's creating, sorry, everything is very much based on where you run these commands. This network admin card, it's basically saying you're an admin for the chain code, not for the blockchain network. And this is kind of just a user, the reason why they've created this is so that way that app that I was talking about, the app can run transactions on behalf of the users that are registered. And they're all going to be going through that network admin credentials, if that makes sense. So what Composer has is this other piece that call it the Composer REST server. And all those transactions that we had created, the creation of participants, all of these things translate into actual transactions on the network. And now, instead of having to go and write out these command line or sending in one-by-one post requests into Fabric, what Composer has created is this app that kind of, let me show you the API in a visual format. Okay, so now you have all these APIs that are associated with creating a bank, creating cash to coins, all that kind of stuff. And this you can easily take and give it to a developer and say, hey, these are the things, I need you to create an app for this, right? That's a lot easier. So now if you think about it, we haven't really dealt with anything related to how the blockchain actually works. We've used blockchain, we're going to create an app for it, but we haven't had to worry about what actually goes into the thing, and that's kind of what this tool is. So the other part of this, let's go here. Inspect, okay, let's see if I can make that a little bit bigger. Okay, so what we have here, I mean, this is a very, it's made for demo purposes. A typical thing when you put your credentials on something like this, you would want some kind of login, you want some kind of authorization to get in. So what I have on the right side is a console that's going to show you what requests are being made, what links are being done. So I'm just going to go through a very simple example here. So you can see we have a get all residents. That's that query that we had created before saying, I want to be able to query this. And so here I'm going to do an add resident. I'm going to put my name. Let's say I have 100 coins, and let's say I generate about 1,000 of kilowatt hours, and I say I have $100 USD. Submit that. And if you watch on the right side, you can see all the API calls that are being run. And these are actually going to translate into calls that are going to be done onto the network. So I've created that. Let's add another one. Minute 2, we'll say John Smith. Let's say they have the same coin balance. Maybe they don't generate as much energy. We'll say they have the same cash value. So with that, and again, you can see all of the different transactions that are actually being run. I'm going to give it a second. And if you remember what I was showing you guys on the test side of that composer, like the way to test your network, you can see that if I pull one of these out, oh, it's not letting me filter, but they have all the, if you were watching, they had the JSON output that was showing exactly what was being given to us on the Composer Playground. Okay. So then, the nice thing to do here is let's do a transaction. So before I do this, I kind of want to show you guys what's happening on the peer. So get the better. So there's a lot there, but I'm going to show you. So I'm going to create a thing, producer, let's say me. The consumer was John. Let's say I want to give him 100 units. It's currently the difference is 1 coin per for kilowatt hour. Execute this transaction. You see this transaction ID? That's going to be able, we should be able to find that transaction right here, and it shows you which block and everything. So these are translating into direct calls into the blockchain network. I mean, we can go through all these logs, but really I'm just here to show you that this is working. And then here, if I go back to the participants, you can see that there's been a change, right? I've gotten 100 coins more, and I've lost about 100 in my energy because I've given it to John. And then my cash balance is the same because we use coins to transfer for energy. So I mean, that's basically my demo. I mean, there's a lot more things you can test out, play with. The idea is, I mean, if you're interested in this, this is like the code. It's on the IBM organization on GitHub. And then again, there's tons of different code patterns and examples. And if you want to talk to me more about this, I'll be around today. I'm also going to be at the booth. Yes?
I have 2 questions. One is, where do you specify the fabric? Was it at the time you set it up?
So when you create the peer, the card, that's where it's going to determine the channel.
The other question I had was, one, you had told me that you can specify the peers that can, the endorsing peers.
The endorsement specification.
Oh, so that piece is kind of being hidden away by this REST server. The REST server is taking care of figuring out, because when I create that peer card, it actually has an idea of what the network looks like, right? When you create those cards, it has an idea of who are the endorsers, what the policies are.
The question is, in the full-blown scheme of things,
Mm-hmm.
the client gets to decide
Yes.
what subset of the endorsers it wants to
Yeah.
send the simulate transaction request, the proposed transaction.
Yeah, so this REST server gets to decide that. That's actually the client. If you think about everything, the REST server is the client of Fabric, not the application that we've created.
But this may be a simplification that the composer has done.
Yeah.
If you do your own thing from the
If you do it by hand, yeah.
SDK.
If you do it by the SDK, what you do is you give it a file that says, these are the peers that I want to get endorsement from.
Okay, so it's part of the SDK, the client SDK that
Yeah.
specify which peers
Yeah.
the endorsing peers that take care, that are involved in the transaction.
Yeah,
right?
yeah.
Okay.
See, whenever you use something like this, composer and so on, they are making some decisions on your behalf. Right?
Yep. So this is kind of like step 1. And then the step 2 is we have a REST server, right? This is like the client, and then the application is talking to that. And this piece right here is where this is kind of has the SDK built in. So it makes decisions about who gets in, well, what peers to talk to and all of that, if that makes sense. So this is just to deploy and install. That's what we use Composer for. And then Composer helps you create this REST server.
So the terminology is what runs on the client side is called application.
Right.
And what runs on the server side is the smart contract or chain code. I wish in the Fabric, which is the code that runs on the client side.
And the fabric that you're referring to is that
The BC network, yeah.
it's called fabric.
This is just blockchain, right? The idea is our implementation right now is Fabric. But the idea is Composer could work with any number of blockchain
I
networks.
very vaguely refer to that as
Yeah.
a potential future.
Yeah, currently it does not. So maybe I should be specific. Yeah, Composer does not support anything but Fabric right now, but the idea is to be able to support other blockchain networks. And as the open source in me wants to call this a blockchain network, not specific. Because I want to get the idea of what these things are doing, right? This is a network, this is a tool that is helping you manage that network. Yeah,
I understand. Thank you.
okay,
Very well done.
thank you.
Shweta.